So here in this particular one, we have a system of three blocks here. I'll just give you the gist of it. M1 initially moving is going to collide with M2. They'll get stuck together or couple together. And that system, after coupling together, will strike M3, and then all three will couple together. On that, it wants us to find the ratio of V3 compared to V1. So V3 over V1. So if you need to, pause the video, read it to yourself so you get the hang of this. Other than that, I'm just going to get going, okay? Here, I'm just going to break it up two different collisions for you. This is a typical strategy. So here, the first collision will happen between M1 and M2. So I'm just going to set up M1 being 16 times M2. So if you read the problem here, M1 is given as 1.6 kilogram. M2 is given as 0.1 kilogram. So if you think about it, M1 is just 16 times M2, because 16 times 0.1 will give you 1.6. So M1 can be rewritten as 16 times M2. You don't have to do this for this particular problem. You literally can just plug in 1.6 and 0.1. I just like to do this strategy because it will cancel M2 out. Here, I'm just going to make the statement that PI, the initial momentum of the system, has to equal to the momentum of the system in the final frame. Initially, though, there's only one object moving, and that is M1. And then afterwards, M1 and M2 are coupled together, and it moves off with the speed of V2 in the diagram. So I'll just stick to the variables given in the diagram here, V1, V2, and V3. So on my left side of the work, I have M1 because it is the only one moving. It is moving at an initial speed of V1 given in the diagram. And on the right side, you notice here I have M1 plus M2 in parentheses because they are going to couple and they are going to move together off with some speed V2, as stated here in the middle diagram here. All right, on that, I'm just going to substitute out M1 for 16 M2 because I said earlier that because the values given here, M1 being 1.6 kilogram, M2 being 0.1 kilogram, so M1 is just 16 times this value here. All right, so here M1 is substituted out for 16 M2 on both sides, so I can just condense the right side of the equal sign. 16 M2 plus M2, which is giving me 17 M2, combining like terms. As you can see here, M2 is going to cancel out. Therefore, to solve for V2, I can just divide both sides by 17 to get rid of that. So here, I just have 16 times V1, or V1I if you want to call it that, because it is the initial frame. But V1I is just 2, because the problem says that V1 is just 2 meters per second. So 16 times 2 will give you 32. And 32 divided by 17 will give you about 1.88. So I know the speed of the system after block 1 collides with block 2 and couples together. Okay. All right. So here's the second collision, and now the system of M1 and M2 with some speed V2 is going to move forward and it's going to collide with M3, and all three will now be stuck together and move off with some speed V3. So this one's pretty easy to do. So I'm going to set up the second collision. Once again, initial momentum equals the final momentum. But my initial momentum is now M1 plus M2 times V2. It's M1 plus M2 because they're now stuck together. And it moves out with some V2 that we just calculated here in the first part, which is 1.88. And on the right side, you have M1 plus M2 plus M3 V3 because all three now are coupled together. So you need to put this in parentheses. So the total mass of the system here. Other than that, here, if you want to, you could use the same strategy that I did here, where you can write M1 in terms of M2. But here, I'm just going to plug in the values. So just to show you, if you want to, you can rewrite M1 in terms of M2, or you can just plug in the values given to you. M1 is 1.6, M2 is 0.1, so 1.6 plus 0.1 is 1.7. V2 we calculated in part, or in the first collision, is 1.88. And then all these masses, so if you look at the problem, 1.6 plus 0.1 plus 2.9 will give you a sum of 4.6 kilograms. And to get V3 by itself, simply divide both sides by 4.6. So 1.7 times 1.88 will give you about 3.196 divided by 4.6 will give you a value of 0.695. And that is how fast all three blocks will move off to the right after they all get stuck together. But the question didn't ask us for V3. It asked us to find V3 over V1. Well, we just found V3 being 0.695. V1 is given to us as 2 in the statement, once again at the very first line here in the wording. And on that, 0.69 divided by 2 is 0.35. So that is to break up two collisions for you, okay? However, if you don't want to break up two collisions, you can actually just do it as one entire system. So here, my second strategy, I'm just going to do system. Here, I've chosen to write M3 in terms of M2. Once again, you don't have to, but M3 is given as 2.9 kilograms. if you look at M2 here, M2 being 0.1, so if you take 0.1 times 29, you'll get 2.9, and it matches with M3. So I can say that M3 is 29 times as much as M2. Or you can just use the numbers and plug and chug. All right, here's the system. The initial momentum of the system must be converted to the final momentum of the system at the very, very end after the second collision. So I'm just going to bypass the second collision. Okay, once again, I'm going to bypass the second collision. I'm just going to literally go from start to finish. I'm going to bypass this middle diagram. So initially, momentum in the system is contributed to M1 because it is moving initially at a speed of 2. And then after they all collide, you have M1 plus M2 plus M3 equals, times V3. So all that needs to equal because it's a conservation of linear momentum. M1, okay, I can rewrite as 16M2, which is right here once again. And then V1 is given to us already. And on the right side, M1, I can break up into 16M2. And then M3, I can substitute it out for 29M2. Or, once again, you can just plug in values. So you notice here on the left side, everything stays the same. On the right side, though, I can do 16 plus 1 plus 29. That'll give me 46M2 times V3. M2 will cancels out. So to get V3 by itself, you would just divide both sides by 46. But we know what V1 is. V1 is given as 2. So once again, it's be 16 times 2, which is 32. 32 divided by 46. It'll be about 0.696, which is pretty much similar to 0.695 in the previous strategy, give take rounding error. And then once we have V3, we can simply find the ratio of V3 over V1 as stated. Once again, in the problem, it says find V3 over V1. So V3 being 0.696 using the strategy, V2 being 2 because that was given. So if you simplify this, you'll pretty much get 0.35, which is the same ratio as the last strategy. So this one I like. It's a lot shorter, it's a lot quicker, as long as you know that momentum must be conserved. So whether you can go through the middle guy and then go to the third guy, or you can just go from start to the third guy, bypass the middle guy. Okay, all right, stay nerdy, don't be whack.